Hi, I'm David. Welcome to Tramex Talks. Today we have joining us Robert Higgins. Good morning, Bob.
Good morning. Thank you for having me.
You could tell our viewers a little bit about your background as a concrete consultant.
Well, back in 1976, I started getting involved with concrete waterproofing and making waterproofing, and it expanded into restoration and waterproofing of underground structures, parking decks, bridge decks, even highways and bridges. And then in the early 80s, we started getting involved with flooring moisture correction. And it was very interesting because there were so many misconceptions in flooring. I actually spent just as much time trying to correct the terminology as I did trying to educate people on how to fix moisture problems with floors.
Interesting. So with all your years dealing with the flooring industry, Bob, I'm sure you've seen that moisture issues seem to continue to grow. What is your take on that?
If you look at it from a historical perspective, which I can now because I've been in it long enough, when it first started out, floor moisture issues were fairly uncommon, where you would see it every once in a while. What really started getting bad is when EPA kicked in, they started changing formulas, or actually were forced to change formulas by eliminating VOCs and these adhesives. Well, that kind of caught the industry with its pants down, and they had a lot of adhesives that came out were just terrible. They would remain sticky, they would re-emulsify without even being alkaline, and they had all kinds of issues. So a lot of those issues stuck, and they persist today, even though the formulations of these adhesives are vastly different and a lot better than they used to be. And
Interesting.
And the adhesives today are the most water resistant I've ever seen. I've taken adhesives that are manufactured by most of the major manufacturers. I've laid them up, stuck them in buckets underwater, nothing happens. So when they keep touting how moisture sensitive these adhesives are, that's not true. That is not true anymore. So we have to get away from that, but that persists.
Maybe you could talk about the different types of moisture testing and their effectiveness and what they can tell us.
Okay, I'm glad you brought that up. Most of the moisture test methods, calcium chloride, humidity tests, moisture meters, they're all pretty accurate. I've evaluated them over a period of several years, and the biggest problem is the interpretation of the data. Now, it's accurate for the condition of the concrete and the condition of the space. That is not being taught, that is not being interpreted correctly. And in fact, in this competitive market, there's methods that are touting that they're superior to other methods. Well, there's no superior method other than what kind of data you get out of it, how useful the data is. And that's our biggest problem.
So out of the testing that's out there, you mentioned calcium chloride. Maybe you could mention the other common tests, and then the important thing, as you're pointing out, is how to interpret data and what does it mean. So with the tests out there, maybe you could get to what's the most crucial information when putting down a floor.
With calcium chloride, it's actually pretty accurate, but it's almost never done correctly. I have, over the last 10 years, the calcium chloride tests I've seen done in the field, a bare minimum 90% of them are done incorrectly, so the data is worthless. So I have quit recommending that method, because if they can't do it properly and they're not being taught properly, stop using it. Just don't use it anymore, because it's of no value. All it does is cause confusion and gives you bad data. Humidity probes do not test moisture in concrete. They test moisture in the airspace. That's an important differentiation, because moisture in concrete is generally in a liquid form. The moisture that's in the airspace is supposed to be correlated with the moisture in the concrete. That would be true only if the concrete were not alkaline and didn't contain hygroscopic elements. With those materials, that actually pulls moisture from the air and can actually suppress the evaporation of water, which will lower the measurable humidity. So humidity tests can actually be more misleading than helpful. So
Interesting.
it is dangerous to use those as an indicator of moisture in concrete. You can have concrete that's virtually saturated and indicate relative humidity in the quote unquote safe percentage.
And the interesting point about that is this is the most common test currently in the flooring industry.
And that's probably why there's more claims than there ever was before. The claims are not getting better. They're not improving. I remember a flooring article where they were basically stating how testing needs to come into the 21st century. And, as we head into the 21st century, about how testing, if it were so accurate, why are we still having problems? Well, that's a good question.
Yeah.
Another question we can add is, why is it getting worse? If testing is so effective, it should not be getting worse. It should be improving. It is not. There's inspectors and there's mitigation products popping up all over the place, and everybody's busy.
Yeah. So from your experience and your research, Bob, what is the most effective way to analyze a concrete slab for being ready to receive floor covering?
I actually have to be proprietary in this because I would say moisture meters, but that's not true. Tramex moisture encounter I found is the most accurate, both by historical use, where we used it in tunnels and for waterproofing. It's actually been weighted against other methods of testing that they were going to use, and they wanted to verify its effectiveness, and they used Tramex as the baseline. Where I really got convinced, and what was very compelling, I saw this study done in Finland on bridge decks. Well, bridge decks undergo some of the most extreme conditions, even more so than road surfaces, because they're exposed, they're suspended in the air, so they have no insulation at all. So they're exposed to all kinds of temperature changes, weather changes, everything could possibly be exposed to concrete. That's what a bridge deck will go through. That's a baptism of fire. And what they used to evaluate the different methods of moisture testing was a gravimetric. Now, gravimetric is the most accurate way to test moisture, period. There's nothing else even close. That's been established in virtually every industry that evaluates moisture content, whether it's grains, pharmaceuticals, medicines, foodstuffs, it doesn't matter. They all use gravimetric. So they use that as a baseline. Well, gravimetric from a practical standpoint can't be used for floors because it's just too complex, the sampling size too small, and if you got enough sampling, it would be prohibitive in cost, and you'd have a very badly damaged floor. So it was impractical. So as accurate as it is, you can't use it. But when I was reading that VTT study in Finland, I found there was almost a direct correlation between the moisture levels as indicated by the Tramex moisture encounter as there was with the gravimetric. That was very compelling, very compelling. That finally gave me a benchmark to go off of where I could say with absolute certainty, this is the way to test. This is the most accurate way to test. Now, let me warn people that only tests moisture. It does not tell you where it came from. No device, no method does that. That is part of this education process, is we need to first find useful data, and the most useful data, if you want to find out what the moisture content is the Tramex moisture encounter. But you need other data that's entered, because moisture alone does not cause failure. It is the vehicle for failure, but it doesn't cause it. That'd be like blaming a freeway for traffic accidents.
Yes, I see. So generally, the consensus is that only viewing the moisture in the top 3/4 is not enough information because the problems are coming from deeper down in the slab. Is that a true conception?
No. That has been an assumption that is run through, and even with all the organizations, that assumption has been bought into as being fact, when in fact it isn't a fact. Most of the moisture originates from the ambient conditions and usually from the surface. It's even been stated that this is a predictor of moisture because what will happen when you put a floor down over the surface, the moisture is going to equalize. Well, it's always done that. So why were the problems less frequent earlier when we weren't testing? Testing's actually produced its own issues. but also so has the rapidity of the construction schedule. They don't have the time to wait anymore. They go, go, go. So what happens, you have these different trades that are on top of each other. When you have people in the room putting in materials, water-based products, you're adding moisture to the air, and that's being fed into the concrete. The 3/4 inch depth of the concrete is the most important area. That's the gradient portion of the concrete. That's what participates on an hourly, daily, weekly, monthly basis. The rest of the concrete doesn't participate that rapidly because water is incompressible. Water does not push through water. It's got to be removed first. So the water that goes in has to be removed. So when it's fed in from the surface, the water from underneath can't come up. It doesn't work that way.
But what about the idea that a lot of these failures are being caused by vapor emissions?
No. Water vapor does not cause failure. Every mechanism of failure has been in the presence of liquid water. Every single one. I've not seen an exception to that. Oh, excuse me. The only exception I've seen is when you put down a water-based product and it slows down the curing process and they cover it up too quickly. That's the only time. But in a set cured adhesive, that doesn't happen.
Interesting. So if it's not vapor, then what would you say majority of the issues are that are plaguing the industry?
Well, it isn't water vapor that causes the problem. And actually, most of the time, it's not even moisture. Moisture creates a vehicle for the damage. Now, a lot of times, when we brought in the hygrometer, that's part of the moisture encounter, and moisture meter along with infrared thermometer, we've been able to catch issues that are being introduced at time of installation. I'm going to give an example. I remember a few years back, there was a project in San Diego. It was a high-tech building and very, very critical installation. I was brought in because they had an elevated moisture issue, and I was representing the moisture control company at the time. So when I looked at it and I saw that what the moisture levels were versus what the quality of the concrete was, and it was water cured, there were no curing compounds, so I know it was done correctly as far as the calcium chloride method was used. I said, well, that can't be the issue because concrete of that quality can't have that high of a moisture vapor emission level, so it just can't. So I think it's coming from the air, the ambient conditions. And so we were debating that, and there was 8 of us in the room. Well, thankfully, I had the hygrometer on with the Tramex meter, and I left it on while we were talking. When we started the meeting and walked into the room, the relative humidity was only 52%. When we finished talking, it climbed all the way to 78%. I said, now I'm absolutely convinced that's what it was. This is created by the ambient conditions. So let's recreate the installation, see what happened. So they decided to do that. So they brought in the installer, same exact flooring materials, and they started, and the relative humidity was a little higher. It was about 55% when they started. Well, when they finished spreading the adhesive, the relative humidity in the room climbed all the way up to 90%.
Wow.
It was a water-based adhesive. So they put the floor down, and predictably it failed. Because what happens is the concrete was cooler than the room. Water moves to the cool side. So what happened, it created its own dew point. So even though it's skinned and is set up the way it was supposed to, according to all the instructions that were given the installer, so it wasn't the installer's fault, they did everything correct, it still failed, and failed in exactly the same manner. They said, well, how do we fix this? I said, we use fans. But unfortunately, because these rooms are so small, we're going to have to bring in a dehumidifier. So we were testing the floor, and the Tramex meter was pegging a little bit over 5. It's about 5.5%. So we put the fans on the floor. After about 2 hours, it brought it down to under 4.5. I said, now we're ready to go. But we have to keep the fans on, and blow it, because we tested around all around the floor, and the floor was dry. It was all under 4.5%. I said, now what we have to do is keep the air moving, but we need to put on the dehumidifier and keep the humidity in the room at less than 60%, keep it between 55 and 60%. So they did that. And as they spread the adhesive, let it tack up, they put the floor back down. It was so well adhered that they were just storing in the floor trying to do the pull test. They couldn't get the floor.
Really?
So exactly the same conditions, just by controlling the relative humidity in the room, completely cured the problem. Now, to show you how important that was for this project, a shutdown for this project, there were 12 rooms, was $1 million per day per room if they shut it down.
Goodness.
That's how high tech this thing was. So this is big stakes. So they went ahead and duplicated that effort in all 12 rooms. It went perfect. So even though I was selling a moisture control at the time, said this is not a moisture control issue. We could have slapped our magic juice down here and would have seemed to have corrected the problem, but we would have fixed nothing.
Right. That brings it up an interesting point, Bob, is generally testing isn't happening at the time of installation. And it seems mostly because the recommended testing is drilling holes, and it's not something that installers can do easily. But what you're presenting is something that can be done at the time of installation and repeated, and it's a one-time investment into a meter, not a continual investment into relative humidity probes.
That's correct. And it's funny is that's probably the most sustainable method you can possibly use because there's no repeated costs.
It also becomes a green method as well.
Yes, absolutely. And the thing is the repeatability. You're not restricted to what areas you test. With a humidity probe or calcium chloride, you're stuck with whatever area you test, and you can't just randomly test other areas without a lot of prep, drilling into concrete, grinding the concrete, doing all kinds of things. You just stick the meter down.
So maybe you could, again, give the simple points that you were presenting of doing a test like this. You mentioned using a surface meter, using an infrared thermometer and a hygrometer. With those 3 points, what am I looking for? I know the topic of dew point came up. How do I check for that?
It's funny. I'm going to have to digress a little bit. When they do the initial testing, nobody tests for dew point. I stand corrected. There are a few people now testing for dew point because they know it's an issue. Now, once they qualified that, that's fine. You qualified that the concrete is in a condition where we can install a floor. That does not qualify it at time of installation. Those need to be separated. Let's do the initial qualification, but you need to test that correctly. That in itself is something that people need to be taught. They're not being taught that correctly. Even worse is they're not testing at time of installation. In fact, I don't know of anybody who is. Now that is where almost all the problems are being introduced is at time of installation. As I've worked with these different installers over the past 5 years, we've estimated that they've saved in the neighborhood of $10 million, and that's only with a handful of installers.
Wow.
I mean, and that's a drop in the bucket to what the industry is experiencing. Now imagine, again, let's digress to that article. Well, if moisture testing is so accurate, why are we still having problems? Well, if you use this method of using the hygrometer, using the moisture meter, and using the infrared, and you use it properly, it's really easy to use, it's easy to learn, it's easy to understand, and the repeatability is really good, especially when you can date stamp and time stamp everything, and it even gives you your GPS so you know exactly what's going on. All this information is not only accurate, but you've got legal protection. You've shown everything that you've done is date and time stamped, and you've located it. So, and that's something we used to always have to do by hand, but that's still not, so, are you sure you took it at this time? That, whereas with the date and time stamp, yes, absolutely. There's no question. You didn't do that.
That one.
Yeah, it's not after the fact. Because unfortunately, people have entered data after the fact, where they're trying to, oh no, when was I out there? Oh, okay, this is good now. Or they're asked questions and they don't know, so they just put the answers in to make it look good, to make it look like they followed instructions.
That makes a big difference. So with our new meters and the Bluetooth app, that feature is allowed that every test can be geotagged, and therefore there's no question of when, where, and what the test was.
This is the best protection for an installer because you have a chain of custody issue that's unimpeachable. Here's the hard data, here it is, and you can't really contest it because there it is. It's all stamped. It's all official, and you can't phony that information.
So I'm going to bring you back to the point again about the test. So with these three instruments, what am I looking for, and how do I use them?
What we're looking for at the time when you're testing is ambient conditions that can lead to moisture issues. One of my favorite examples are basketball games. People say, well, there's not that much moisture that can come from the air. Oh, yes, there is. And NBA games, college games, high school games, even games on playgrounds, they've had to cancel because of dew point. In fact, if you go on an internet search and put in damp basketball surfaces, cancel or postpone, you'll get page after page after page of examples where it shows an NBA game where as people are coming in, the floor is colder because it's a parquet floor, and they're usually when they roll out the parquet floor, there's usually ice underneath it because they use it for hockey.
Right,
so it's very cold. So as people come in and the humidity climbs and the air temperature is too warm, what'll happen is you get a layer of water, and no matter how many times they mop it up, it keeps getting replaced. Well, that's water keeps getting fed into the concrete over and over again, and can do that for hours and days on end after the initial test and into the installation, and even during installation. I have seen moisture being introduced where they actually had to slow down the installation, put fans back on the concrete, moisture test again before they continue. And it's eliminated these problems they would have had if they had not done that.
So this is really the installers need to be aware and have the ability to get a handle on the conditions at the time of installation. One
In fact, any quality installer, if they came out with that device and using those techniques after being trained, one installer here in Florida, they have 6 offices. They used to have monthly issues. They didn't tell me how many, but they said it was monthly. They're down to less than 1 claim a year.
Wow. That's amazing.
Yeah.
So again,
the amount of money they're saving, it's ridiculous. And the equipment they have, the only thing they've had to replace is the infrared thermometer because it was stolen.
With COVID-19, everybody wants one, I guess.
Exactly.
So with that thermometer, what am I doing? Can you give me how to understand how dew point is affecting the surface of the concrete, or the relation of dew point to surface temperature? Okay,
well, concrete will enter dew point earlier than just about anything else because it has these hygroscopic salts. And what a hygroscopic salt is, it means it actually pulls moisture from the air. So it actually can hit dew point before actual dew point in an unaffected area. So you have to be really careful with that. So my precaution is to follow what the European standard is 5 Celsius. If you're within 5 Celsius of dew point, don't install. Well, that's about 10 degrees. I agree completely. But what happens within ASTM standard, and why this gets around and people and they don't pick it up, is they're given this window of 65 to 85 degrees. Well, if your concrete's 65 degrees and your air temperature is 82 and the relative humidity in the room is 55%, the concrete's at dew point.
Yeah.
So even within ASTM standards, you can hit dew point. Even though you did everything right, everything wrong can happen.
So the main thing is to understand what the surface temperature is in relation to the dew point in the room. And you want to be at least 10 degrees above that to create a safe cushion because of the salts in the concrete that can draw moisture.
That's correct. And when people have done that, even a couple times have done it grudgingly, said, okay, because they've been taught to really adhere to that, because if you're not having failures, don't deviate.
Right.
So when they're using the
until one comes to bite you.
Yeah. So when they're using the Tramex meter and they're doing the digital hygrometer, testing the air temperature and the humidity in the air, if the temperature is remaining the same, but the humidity starts climbing, they're still looking at that differentiation. So as long as you stay away from the 10-degree point, you're good. But always remember, even if you don't have sophisticated equipment, The bigger the difference between the temperature of the concrete and the air, the bigger the problem. The more likely it's going to happen. What's really, really irritating and frustrating to me is almost all the moisture claims are completely avoidable. People are being sued over something they can be taught that's really easy to use, doesn't cost repeated dollars, and we can literally save over $1 billion a year in claims by just applying practical knowledge and a simple way of testing and monitoring the site at time of installation. If we do that, that $1 billion is going to drop down to just nuisance.
Right. The goal is to solve the problems, and with the proper information, I think that can happen. Well, thanks so much, Bob, and we'll check back with you in the future.
Okay, thank you. Thank you for having me.
Thank you very much. Thanks for joining us. We'll see you next time.